Welcome and thank you for joining us today for Adapting Performance Visibility to New Technology Trends. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speakers are Seamus McGillicuddy, Research Director at Enterprise Management Associates, and Sergio Bea, VP of Global Enterprise and Channel Sales at Accedian. Seamus has more than 12 years of experience in the IT industry as an industry analyst and journalist. At EMA, he is the Research Director for the Network Management Practice. Sergio draws on more than 2 decades of telecom industry experience and has worked for Fortune 500 global corporations in key strategic roles throughout his career. And before I hand things over to today's featured speakers, I wanted the audience to know that Seamus and Sergio will be concluding today's presentation by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded and you will receive a follow-up email from EMA later today that will include resources from today's webinar, so I hope you will check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Seamus McGillicuddy. Seamus?
Thank you, Raleigh, and thank you everyone for joining us today. I will be speaking today about adapting your performance management, performance visibility capabilities to new technology trends that IT organizations, IT operations teams are seeing impacts from today. As an agenda, I'm going to start out talking about some of the gaps that my research has shown to exist in mainstream network performance management tools today. And then we'll go into how those tools are affected and should adapt to certain trends that we'll be exploring in this webinar, starting with software-defined technologies, which in this context will include so-called data center SDN solutions and then software-defined wide area network technologies. Then we'll look at cloud service impacts, specifically infrastructure as a service and to some extent software as a service. Then we'll look at the impacts of containerization of applications on performance management and performance visibility, and then we'll close it out with TLS 1.3 encryption, which is of which adoption is ramping up pretty rapidly and will be impacting layer 7 visibility significantly. So today's network performance management gaps, just a review of what we've seen to give you a sense of what enterprises are dealing with, what your peers are dealing with, what you may be dealing with. We're seeing gaps in functionality in performance management solutions. 81% of enterprises said they're increasing their performance management tool investments by 2021. And the primary drivers of that investment are either upgrades or purchases of new tools to close gaps in functionality or visibility. That speaks to new requirements of network performance management tools, but it also, in a lot of those requirements, will be driven by new technology and business initiatives. Where are those gaps in functionality and visibility? We asked those same enterprises in this research, which was published in May, what are the initiatives driving your NPM investments? Network security, cloud connectivity, data center SDN, IoT, and NetOps and SecOps alignment were the big ones. And those kind of echo or reflect some of the trends that we'll be covering in this webinar, such as encryption, cloud computing, data center SDN, IoT to a lesser extent. We're not really touching on that in this, but I can give you a sense of why people are increasing or purchasing NPM investment and NPM tools to close gaps around these technologies. We also asked them to tell us what their tools, what kind of challenges they have in terms of functionality in their network performance management solutions. And the two big ones, or top two, or I guess the top three, were no real-time insight. So they're basically looking at data that is not necessarily reflecting the moment, the real time. Aggregated data, so there's no granular info. Maybe they're relying a lot on on some metadata is generated from monitoring data, and you can't really click down to find out more information, or maybe you're relying on like NetFlow, which doesn't necessarily give you packet information. And then conflicting or inaccurate data, which reflects the fact that you're collecting a lot of different types of data. Some of it may, if you're using multiple tools, you might have a hard time sort of reconciling what you're seeing in different points of view. What you're seeing in SNMP might not be telling you what's happening from what you're seeing in NetFlow. And also maybe some of the data you're generating or collecting is out of date or bad. Maybe maybe your SNMP mids and traps are not all getting captured in your monitoring tool, and so you're not really seeing an accurate picture of what's happening. And part of the problem is you most likely have more than one NPM tool in your arsenal. In this chart, we're looking at how many network performance management tools an IT organization has. The blue bars are those that are installed. The green line, it reflects those that are used regularly. And one thing you see is there are a lot of tools that are installed that aren't getting used based on the gap between the green line and the blue bars. But also, more importantly, there's just a lot of tools. A typical enterprise has 3 to 6 tools installed, and they're using 2 to 4 on a pretty regular basis. How do you correlate insights across those tools? A lot of people are doing it manually. That's not efficient, and it's prone to error, and you're not going to have a very good end-to-end view of your network. So you want to consolidate insight as much as possible. You want tools that can correlate insights from multiple data sources on your network whenever possible. And some of the most popular sources of data used for network performance management are packets, flows, synthetic data generated by active monitoring tools, or just general network tests, and device metrics collected through SNMP mids and traps and device APIs and things like that. Half of enterprises told us that it's essential to have a network performance management tool that can correlate insights across at least 2 classes of data. The 4 here, maybe some other ones like logs, but it's really important for them to be able to have a tool that can do more than one thing, basically, and do that effectively. And when we ask them how this helps them, you see on the right here some of the tasks that are enhanced by that correlative ability. 93% said it helps them with application performance insights. 90% said it helps them with security event detection. Fewer, but still most, see benefits in being able to see end-user experience insights, anomaly detection, proactive problem prevention. So there's a lot of value in being able to correlate insights from multiple classes of data. And that's something you want to think about as you're modernizing your tools to address certain technology trends. And on the topic of technology trends, let's pivot to software-defined technologies. Data center SDN in today's enterprise is not the SDN that we were talking about like 5 or 8 years ago. Traditional SDN never really took off. If OpenFlow is in today's SDN solutions, it's deprecated and not talked about for the most part. Today's SDN solutions aren't your traditional like disaggregation of control and data plane. It's really about combining a bunch of different technologies that make data center networking less complex and more effective and easier to manage. It combines things like automation tools and policy frameworks and software overlays and device APIs to make everything more programmatic. And that transforms how the network team manages the network and manages policy and applications and service changes and things like that. The 2 leading examples, as you're all probably aware, are Cisco ACI and VMware NSX. These technologies do present visibility challenges, and those challenges were really pronounced when these types of solutions emerged a few years ago. Network performance management vendors have been working to to deal with things like more infrastructure abstraction, encapsulation decodes, whether it's something like VXLAN or Genev, more data to correlate and analyze. You're just collecting more data. You're collecting data from the infrastructure devices, maybe the software overlays and the controller. There's a lot more data you have to crunch and correlate and understand and present to the user and the NetOps team. So how do you solve SDN visibility? There's a lot of things you need to do, but you should look to your NPM vendors to integrate with your SDN vendors' APIs. They started doing this early on and found you get a lot of data out of that solution, but then you need to have technical partnerships between your performance management vendors and your SDN vendors to solve how abstractions and complexity are decoded and presented in a meaningful way. And that leads to the fact that you need to be able to correlate the underlay and the overlay. Every SDN solution is basically an underlay running over an overlay running over an underlay. Even if it's a hardware-based solution, they're basically creating an overlay with encapsulation and stuff like that. And you really need to understand both for an end-to-end insight into what's happening on your network. And so you're going to need to make sure you have conversations with your performance management vendors to address that. Speaking of overlays, there's also software-defined WAN, which also presents visibility challenges. And this is also an overlay technology that runs over your wide area network, and it's doing things like WAN connectivity aggregation and path steering, centralized control, automation, basically making it easier for you to manage your wide area network, especially as you transition from an MPLS-centric network to something that leverages a lot more internet connectivity and maybe 4G and 5G in the future. These solutions are really booming. There's 3 or 4 dozen vendors out in the market, and every service provider is trying to offer a managed service around it. There's visibility challenges around it. Obviously, it's an overlay solution, and visibility that the SD-WAN vendors usually provide native visibility into how their tunnels are performing across your WAN and how the applications are performing across your WAN. But that visibility is usually limited to their overlay. A lot of them don't really even care what hardware they're running on. And so network performance management tools struggle to collect data and understand the data that SD-WAN solutions produce. We asked enterprise practitioners who are adopting or fully deployed with SD-WAN solutions what kind of challenges they have when they try to integrate or facilitate integration of their SD-WAN solution with their IT operations management tools. And the top 2 were the software-defined WAN solution produces data that lacks insight into the transport layer, and also it produces data that lacks insight into the hardware it's running on, which means you need to account for that insight elsewhere through your performance management and visibility solutions. SD-WAN solutions also lack granularity in the data they produce. The monitoring intervals are too long for what they're looking for. I've talked to performance management solutions that have struggled with that, but also struggled with the quality of the data. And if you try to turn up that granularity and produce more, shorter monitoring intervals, a lot of them say almost a quarter of them say there's significant degradation of the SD-WAN solution's performance. So that's an issue to keep in mind as well. So you also have to bear in mind that SD-WAN vendors vary in their approach to data generation. Like they may produce flows, they may support and provide SNMP MIBs and allow you to create, set up SNMP traps. But their implementation of that data generation technology may be inconsistent. It's not really a priority for them because they're really focused on offering that native visibility and thinking that's what you're really looking for. And a lot of performance management, performance visibility vendors have to have long technical discussions with some of these vendors about how to properly implement this data generation. So that's something you have to bear in mind as you're rolling out SD-WAN. So maintaining SD-WAN, you need to have conversations with your vendors about how to correlate the underlay with the overlay and get insights from that. You need to make sure that you can collect hardware metrics for full context. So you need to ask your vendors to partner with SD-WAN vendors for reliable data collection and quality data generation, and consider active monitoring solutions where passive monitoring is insufficient. If you have an active monitoring solution that can send synthetic traffic across your SD-WAN overlay, then maybe you get some visibility in places where you have gaps, and that can be effective. So cloud services, just a couple of quotes from people I've talked to this year to show how network operations teams are struggling to see into the cloud. One senior network architect at a large North American government agency told me that his biggest issue with the cloud was visibility, how applications are behaving in the cloud and how the cloud is behaving. He needs to see more than bandwidth and connection health and connection level into the cloud. But he can't get it to the extent that he wants it. So he said if he had the monitoring in place that he needs, he'd have a better grip on the cloud, but right now he doesn't have it. And then you see the senior network architect at a large media company said he struggles to see cloud networks from a holistic point of view. He can see individual things like, okay, this is what's happening in AWS right now. Here's what's happening in Azure. Here's what's happening in my data center. Here's what's happening in my enterprise network. But there's nothing that shows him that things are really working well end-to-end across the cloud, and he really needs that end-to-end visibility in a multi-cloud environment. So one thing that a lot of these enterprises in my research tell me is they're trying to find ways to capture traffic data to give them some good insight into what's happening in the cloud. 98% said they were capturing some kind of traffic information or data in their infrastructure as a service environments. The most popular data they're collecting, NetFlow or IPFix or some other flow technology, cloud flows like VPC flow logs, which are generated by your service provider, and some NPM vendors are definitely consuming those. And then synthetic traffic from your active monitoring solutions, those are the big three, but also packet metadata. Being able to stream packets through some sort of probe you deploy in your infrastructure as a service environment and generate some KPIs from that packet information and then send it to some tool you've got deployed probably in your infrastructure as a service environment. Capture of full packets, pretty rare unless you're in like a really intense forensic analysis of what's going on. How cloud traffic is used by these NPM tools, these are the top three. When these 98% said they're capturing some kind of traffic in their infrastructure as a service environment. They're saying it was serving security monitoring, performance monitoring, and troubleshooting use cases. The problem is that a lot of network performance management tools let people down when it comes to the public cloud. Still, this is from a survey I did at the beginning of this year. 74% of 250 enterprise IT professionals who are directly engaged in integrating their network with their enterprise cloud strategy told me that they'd had at least one incumbent network monitoring tool fail to address their cloud requirements. So 3 out of 4. They either dropped that tool or they modified it themselves with some custom work to just kludge it together and make it work for their needs. But ultimately, they'll probably have to buy a new vendor buy from a new vendor if that vendor is just failing to do what they need them to do in the cloud, because the cloud is just going to become a bigger part of everyone's overall infrastructure picture inevitably. Why are they failing? The two big ones, cost. They got vendors who are telling them, oh yeah, we'll support your cloud requirements, but you're going to have to upgrade to a new version that will cost you some money, or you got to buy this module that covers cloud visibility. And they're not having it. Then complexity of implementation. Getting the cloud support to work the way they want it, getting it up and running, it's too hard. It's not getting, it should be easier. And then more than a third said that functional execution was just a failure. They couldn't get the cloud support to work the way they wanted it. Maybe it's just like a separate tab, cloud visibility, and there's no integrated insight into the rest of their network, something like that. And then 28% still this year saying that they had a vendor who just wasn't putting together a cloud roadmap, which may have been acceptable like 5 or 6 years ago, but not acceptable today. So we also see that network performance management and visibility technologies need to address some other use cases beyond performance. 99% of the network teams we surveyed in the research I cited just now on the previous slide said they're using their network monitoring tools to discover and assess network requirements of applications that are tagged for migration to the cloud. That's everybody, basically. And 89% say they're monitoring cloud networking costs with their network performance management tools. And 33% said they had to adopt new tools to achieve this capability. So, being able to, bill business units for cloud networking costs or control costs, prevent unexpected costs, things like that, the performance visibility is going to need to give that to you. And then we also asked these enterprises, what are your top business requirements for network performance management tools in your cloud environment, public cloud environment? Number one, scalability. Number two, adaptability, the ability to support things like new abstractions, new providers. So those are things that you need to look at when you're adjusting to the cloud. And then pivoting briefly from infrastructure as a service to SaaS. There's the problem there of having no access to the SaaS cloud infrastructure. You can't put probes in your SaaS provider's data center. You can't collect data on their infrastructure. It's a black box for the most part. 22% of enterprises say SaaS user experience is the most difficult cloud visibility issue they deal with. We've seen rising interest in synthetic active monitoring solutions over the last few years, and part of that is due to the SaaS adoption wave. 54% of enterprises said they're using edge-based active monitoring tools to get visibility into SaaS, and that's going to give you a good sense of how end-user experience is with your SaaS environments. And then 52% said they're using active monitoring based on a vendor's internet points of presence. So that adds up to more than 100% because they're allowed to select more than one tool that they're using to get SaaS visibility. And these are the top two. So containerization of applications. Containerized applications are going to challenge your performance management solutions for a couple of reasons. And our research shows that performance is the number 2 pain point associated with production deployments of containerized apps. So that's important to keep in mind. The sources of trouble, you're going to see a lot more east-west traffic flows where microservices traffic may never leave a physical host. You've seen that with your hypervisor infrastructure. You're going to see it more with containerization. There's just going to be more and more little microservice nodes on containers that pop up rapidly, and that's another thing. Containers last for minutes or seconds, and many NPM tools sample data over intervals that are longer than that, and we'll miss a lot of change. So network performance management instrumentation is going to struggle to keep pace with that change. Here's a view from one infrastructure executive at a very large North American financial services company. He's really struggling with this. He said his biggest network performance management challenge was east-west traffic and intra-device traffic. He said it's hard to get visibility in that, and the expansion of microservices and containerization is increasing that issue for him with small things going to a device and generating more traffic. And he says he's kind of flying blind right now. And he also said that the containers empower DevOps teams and application developers to do things in their architecture that can have significant impacts on the network that they don't anticipate because they're doing all this change on the fly without necessarily involving the network infrastructure team. He pointed to this situation where his packet monitoring tool was seeing a lot of LDAP traffic going on every morning and it was really spiking his network and overwhelming the authentication system. He said that he had to basically investigate and determine that there was a microservice in an application that was caching everything every morning, and the developer hadn't really thought about the amount of traffic that was going to generate. So now he has to find coding problems by looking at traffic on the wire. Most people say that my research has traditionally found that the two leading sources of network performance degradation are the network itself and a security incident. But this development of containerization, I think, and microservices implementation is going to lead to probably increase incidents where just bad application design and architecture is going to hurt the network, and it's just going to drive more need for visibility in network performance management solutions into how microservices are set up. So addressing container visibility, you want to integrate your performance management tools with container orchestration solutions like Kubernetes. If push your vendors to do that if they can, so you can understand the moves, adds, and changes, and collect metrics on resource allocation and things like that. You want to deploy, if possible, virtual probes in your container clusters so you can capture that east-west traffic. And then you want to adopt an analytics platform that can crunch diverse data. As I mentioned in an earlier slide, 93% of enterprises say that when their tools can correlate insights across different classes of data, it improves their visibility into application performance. All right, finally, TLS 1.3 encryption. This adoption is ramping up. Our research on TLS 1.3 found that 98% of enterprises will apply this new encryption standard to inbound connections within 18 months, and 97% will apply it to internal traffic within 18 months. And they can't really hold it back because browser support is here, and regulatory agencies and compliance organizations are adding requirements for it. And what is it? I'm not going to go into in great depth because I'm not the security analyst, but perfect forwarding secrecy is like a key component of TLS 1.3. Basically what it says is no more shared keys on your web servers. Instead, 1.3 generates per session unique keys that expire after a session is complete, so there's no more, it becomes difficult to do retroactive packet decryption because every single session has its own key, and you can't get a shared key and just put it on your decryption proxy or whatever you're using to do passive decryption to get layer 7 visibility into your traffic with your performance management solutions. So NetOps teams are perceiving this as a pending problem. There are a lot of financial companies that are really panicked about this, and we're trying to push back against the development of 1.3 to do something to mitigate the loss of visibility they were anticipating, but they failed in their attempt. And so now your network performance management vendors are going to have to innovate. And encryption is the number 3 data-related challenge with network performance tools, according to my research. And then 89% of enterprises that are adopting TLS 1.3 or planning to say they're expecting it to degrade visibility into inbound and internal traffic. And 23% say that their top concern is their ability to troubleshoot application performance. They're also worried about things like being blind to security incidents that they usually rely on layer 7 visibility to provide them visibility into. So how do you adapt to TLS 1.3? There's a few approaches. You could go back to just relying more on flows and packet headers instead of layer 7 visibility. Packet headers are going to give you that layer 4 insight, but it's going to lack a lot of application context. I talk to a lot of network operations teams that still think that their responsibility and their domain ends at layer 4, and layer 7 is the provenance of the application support team. So they'll probably still be happy, but they won't be very good at supporting their organization. NetFlow will offer traffic insight, but you're going to lack the granularity because when it comes time to dive into packets to get more understanding of what you're seeing in NetFlow, you're not going to have that option with encrypted traffic. You could use active synthetic monitoring, which emulates application traffic with probes and sensors, and encryption is not an issue because it's not actual production traffic. So you are generating the traffic. You don't need to encrypt it. You're just actively looking at how your network health is. But you're still not going to see what specific users experience with a specific session. You'll be limited there. The other approach is to deploy a proxy appliance, a man-in-the-middle decryption device to do active decryption where you used to rely on passive decryption. But that means you have to terminate that perfect forwarding secrecy connection and decrypt it, then send the data for analysis, re-encrypt, and send the production traffic on to the next hop on your network. And that is going to add latency, but more importantly, break the end-to-end encryption of TLS 1.3 and probably violate your compliance regime. So that's probably going to be an issue. There are some network performance management vendors that are looking at different ways to get around layer 7 visibility into packets with this, and I think the industry will continue to innovate on this and try to break through and see that layer 7 visibility in the packet. but right now, your options are limited to what you're seeing here. So final thoughts before I hand it over to Sergio. When adapting network performance management to next generation technologies, you want to think about consolidating tools and trying to correlate insights across different classes of data to simplify your insight into next generation technologies and adapt to things like SD-WAN and SD-WAN. You're going to need new tools, new functionality, new integrations there. You got to recognize that the cloud is going to create blind spots in your performance visibility, so you need to collect the infrastructure as a service traffic where you can, explore synthetic monitoring for SaaS. Containerization is going to introduce rapid change in east-west traffic, so integrate tools with your container orchestration to understand that change and install probes to get the east-west traffic if possible. And with TLS 1.3, layer 7 visibility is broken, so explore new decryption strategies or leverage synthetic traffic, or find ways to live with just layer 4 visibility, but that's probably not good enough for a lot of you. So sorry, I don't have more advice on that right now, but we're waiting for vendors to innovate. So with that, I'm going to turn it over to Sergio and let him talk about these issues to a little more.
Excellent. Thank you, Seamus. And good morning, afternoon, and evening, everyone. Thanks for having me. I'm excited to be part of this webinar, and hopefully you'll see value of all the insights that has been shared so far. So what I'm going to spend a few minutes first to just introduce Accedian for those of you that don't know us. So we are a global company based out of Montreal, Canada, and we consider ourselves our performance and end-user experience experts. We really focus on network and application performance solutions. And we have a very strong pedigree, 15 years in the market, and we're serving customers in 86 countries. We are used by 75% of the top 50 carrier service providers in the world. And some stats here, we have over 500,000 performance elements deployed across the world, and we assure networks that serve over 2 billion users today. And of course, these technologies are deployed in enterprises across multiple verticals. So when we've actually did a few surveys in the last in this year, and what is the new CIO dilemma today? So it's really the fact that the IT organization is now truly responsible for customer experience, whether it's internal customers or their external customers, and CIOs believe they are responsible for that. However, at least 35% of them don't think they have the right tools to address this issue. And Seamus just shared some of the new technologies trends that validate that the IT environment has drastically changed in the last decade. Well, now the CIOs have the challenge not only to cope with the new reality, but to ensure that they're in control of their customer experience, and at the same time, they have to ensure operational efficiency and make sure that they're supporting and enabling the business. So this acceleration of cloud adoption, highly distributed environments, and growing complexity, the interaction between the user, the application, the network has drastically changed, and it's a big challenge for enterprises today. Seamus shared a few stats. The average enterprise has anywhere between 3 to 5 tools, and that responded to a traditional siloed approach to performance that has been in place for 2 decades. Well, it doesn't work in today's world, right? You used to have a tool to monitor user devices and a different one to look at the network. and then some companies have specific server monitoring tools. You have your application teams looking at specific critical applications. Well, with the adoption of public cloud, more and more SaaS deployments across that environment. The execution of infrastructure as a service or platform as a service solutions today, well, that becomes way more complex and unpredictable for IT teams to monitor and gain visibility, right? So we need to start looking at tools that can actually integrate views across all these complex environments. So let me tell you a little bit about our platform, how it works. Our platform is called Skylight, and if you look at this diagram from the bottom up, the first thing I'll say is our solution is both vendor agnostic and also network agnostic. And what I mean by this is we can be deployed in wireless networks, in wireline/business services networks, multi-cloud, hybrid cloud. So it doesn't really matter which type of network you want to instrument. And we have a variety of sensors for all of these network topologies and use cases. And the sensors vary from active synthetic type of sensors. We also have passive sensors that just sit and look at 100% of the traffic across all the environment. Our sensors can be deployed on-prem, can be deployed in the cloud, and I'll talk a little bit about that. But the goal here is that you can instrument this whole new environment seamlessly and use the right sensor for the right case. Then obviously, with a very highly dynamic environment today, Seamus touched upon this several times, you got to be able to orchestrate and turn on and off those sensors and move them around as that environment dynamically changes, right? So that's where our orchestrator comes in. And ultimately, you're going to be gathering and ingesting billions of data points. And you have to be able to extract those valuable insights in seconds and give our customers the right insight at the right time. So not only we ingest all of the data from our sensors, whether they're active or passive, but we can also integrate third-party data. And we're doing this today through our open API architecture. And again, to Seamus's point before, that's what customers are looking for. You need to be integrated into the SDN environments and other third-party vendors. If I go a little bit more in detail, I touched upon this a little, but the sensors itself is a variety of them. From software sensors that can be spin-offs in a VM, right, that don't require hardware if you don't need to. That makes it extremely easy to deploy and scalable and breaks a lot of barriers when you don't have access to a specific hardware device. Or you cannot install a new piece of hardware in a customer location. We also do have some modules or hardware appliances and even small SFPs that can act as a sensor, especially when you're trying to instrument the edge. And then I talked about the orchestration and how can you easily turn on and off that type of deployment, and then the analytics that allows you really to do have macro view for CIOs or executives that are looking at high-level dashboard on how the whole infrastructure is performing. But you can also quickly drill down into the micro detail and troubleshoot a problem right out of the same visualization and analytics tool, and we leverage machine learning and artificial intelligence as well to drive that. So how do we approach some of these key challenges that Seamus was talking about? Well, the first thing requires a big paradigm change in the way that we look at network traffic analysis. And let's break it down in the data analysis and storage piece, and then how we used to capture that traffic. So traditional network performance and monitoring tools, it was all based on access to packets, right? So we would store 100% of the packets, stream them to disk, and we would use the metadata to locate the right packet and do the investigation. Well, guess what? Now you have a huge volume burst. Most of that traffic is now encrypted. And if you're moving that level of data in and out cloud environments, for example, it just becomes completely not cost effective, right? The TCO is not there. So you need to find tools that can actually be deployed in these new environments at a cost-effective way. When you look at the capture, the way we used to do traffic capture, well, normally you would do centralized traffic capture. You would use taps or packet brokers, and normally you would do it in the different data centers, and you centralize and do the analysis that way. Well, how do you cope now with the east-west traffic, for example, across data centers? Or if you have to instrument the edge of the network or dynamic environments or SDN environments, well, that centralized traffic approach is not effective anymore. You got to work with cloud-native traffic resources and be able to distribute the capture and the analysis as close as possible to the environment that you're instrumenting. So how do we do that? Because before, many of you guys have probably heard the phrase that the truth is in the packets, right? Traditional NPM tools had to rely on the packets as a single source of truth. Well, the evolution of the technology allows us today to provide real-time, full-stack visibility down to each session and each transaction with leveraging very enriched metadata, network and application metadata. And before, you would use metadata to guide you to the right trace file. Well, now you can actually use the metadata to make the diagnostic itself. And in the case that you need to go in and look at a packet, you can always use PCAP capabilities to do that. But that becomes now the exception and not the norm. Talking about distributed capture capabilities. Again, this is extremely, extremely important. So let me spend some time on how Skylight works, right? So this talks about specifically our on-prem or cloud sensors, which are passive in nature. So we're on the wire, looking at 100% of the transactions all the time. And we just need a tap or mirror or span port to look at that traffic. We analyze everything on the fly. And those sensors strip out only 0.5% of the overall traffic as metadata for further analysis in what we call our data store or Skylight Analytics engine. And what's critical here is that we can deploy these sensors tightly integrated in the environment that we are instrumenting. And that is huge when you're looking at containers, SDN environments, and cloud, because resource consumption, scalability, things like that are more important than ever. So you can't rely on centralized analysis to do that. Once we deploy the sensors, we strip that metadata, we take it up, we do deeper analysis, and we show the insights that way. Now let's talk about east-west traffic. Again, Seamus mentioned it was one of the key blind spots that IT ops teams are faced with today, right? So the key element on an SDN or containerized environment is really how do you orchestrate the deployment and commission and decommission sensors as the topology is automatically changing, right? And the way we do this, well, first of all, you need to have very lightweight and virtual sensors that can be, again, deployed within that environment. But it's important to have what we call centralized analytics and with multi-segment analysis. What is this? So when resources are moved automatically and the path that they're moving is not predictable, it's important to have that centralized analytics within the environment. And then multi-segment analysis consists in running searches at the TCP or application level on all capture points, but in one user interaction. So this allows us to have a very simple deployment at a very low TCO and be able to cope with the east-west visibility challenge. Again, when you look at this SDN environments, virtual world, infrastructure as a service, you have to look for solutions that are 100% based on that native infrastructure. That way, the resource consumption is negligible, and the TCO is there, and you can actually do it. Otherwise, it's cost prohibitive. The other key thing is you need to be able to scale the solution easily and in an automatic way. Well, again, when you look at the traditional way we've all used to do network performance monitoring, using intrusive monitoring techniques and requiring NICs or network packet brokers, it just adds additional traffic load to the whole solution. And again, it's not scalable, it's not fit for this cloud environment. What about public cloud? I'm going to try to speed up in the essence of time, but public cloud visibility is another key element, right? Seamus mentioned how 74% of the people surveyed say that their cloud migration strategy failed for one reason or another. Well, it's extremely important to be able to instrument the public cloud environment within the public cloud itself. And the way I described how Skylight works, think if you would have to move loads and loads of traffic in and out an AWS or Azure environment. Again, completely cost prohibitive, right? So we do the capture using a small, what we call a cloud packet broker, which is it's really a software engine within that cloud environment that does most of the analysis in there without having to move the traffic in and out of the environment. Another key challenge is how you instrument the edge. How do you extend the network performance capabilities to the edge? Well, we have several ways to do that, again, in a very cost-effective way, whether it's using this SFP compute modules or virtual appliances or micro appliances. Again, moving the analytics capabilities to the edge and just stripping back whatever is necessary to perform deeper analysis. When we look at cloud migrations, everything that I've been talking about really comes to play, right? It's extremely important to baseline the before a cloud migration, ensure that we're testing how the environment is going to look like, and then obviously monitor once the migration has happened. But doing this proactively would allow you to plan for the right resources and avoid the issues that most IT resources are having today as they deploy more and more in the cloud. Seamus also touched around SD-WAN as an example of how important it is to understand the underlay and the overlay. Well, normally SD-WAN vendors will provide you some basic network performance metrics in that SD-WAN cloud, limited to that SD-WAN cloud. But what happens from that point all the way to the end user? You have to instrument that to gain really end user experience. Otherwise, you will be blind beyond that SD-WAN cloud. And again, deploying the sensors that I've talked about, we can extend visibility all the way to the end user. And we can do enhancing the overlay for the end user, or also the underlay with our synthetic active sensors to ensure that all the links are working properly and you're capturing all the metrics. And one of the things we do this at a microsecond level of granularity, so it's extremely precise the way we can instrument and enhance that SD-WAN visibility. Containers. So Seamus explained a lot about the key challenges in containers, and I agree 100%. If I would summarize what's the key issues here in containerized environments, is that normally in traditional environments, IP addresses are the ones that are used as the main reference for configuration and visualization. But in a container environment, IP addresses are short-lived, and they change all the time. So there's no way for you to use that as a reference to monitor the environment. So you have to look at ways, when you talk to your network performance vendors, how are they coping with that dynamically ever-changing environment within containers? And again, look for companies that have third-party integrations into some of the key players in this space, which we do, by the way, and we're working with several of them. Now, it's great that you have the chance to deploy potentially with the technology is there, and now you can instrument some of this new environment. But you just can't stop there, because the way you are consuming today's resources, you have to consume performance and visibility in the same way, right? So look for options to consume performance as a service, for example, which is something that we offer. We also allow you to deploy sensors pretty much at your own leisure. You can turn on and off sensors, and you're not going to be penalized or charged for how many sensors you're turning on or off. The important thing here is that you can dynamically instrument the network, and of course be able to scale up and down as you need to, and always have the ability to get those insights for performance measurements. When we look at encryption, today still TLS 1.2 is what roughly 85% of the market has today. But Seamus mentioned that over the next 18 months, pretty much all of the enterprises are looking to adopt TLS 1.3. And the challenge here is that the certificate names and all of the SSL information is now encrypted, which it wasn't with 1.2. So here the key thing is to work with partners that can allow you to deliver that layer 7 visibility, and that's how we are approaching it today, to provide that SSL inspection capabilities in order to be able to still continue to monitor the layer 7 and all your applications in an encrypted world. So with that, just want to summarize one more thing before we go to the Q&A. Ultimately, the beauty of the Skylight solution is you can deploy the same sensors, the same technology for absolutely multiple environments, different use cases. We're also leveraging the same sensors for intrusion detection, for example, on the security use case side. Again, Seamus also mentioned how that is critical. So you have one single solution to be able to leverage across multiple environments. Thank you so much. That's all I had.
Thank you, Sergio. We have time for some questions, so I'm going to go ahead and jump right into them. Sergio, a couple questions for you. The first is, I have several performance tools in my environment today. Does this mean I need to replace them in order to address these new visibility gaps?
Yeah, that's a great question. Well, the answer is not necessarily, right? If you are using some tools today and you're extracting the value out of that investment, what you would do is look at where you're having visibility gaps with your existing tool, and then, for example, cover those gaps with hopefully Skylight and Accedian, but with another tool that can address that space without necessarily having to forklift what you have. In other cases, if you really are extremely siloed and you have 7, 8 tools, and 4 of them are not being used, like Seamus showing a stat, well, that's a great opportunity to actually decommission some of those tools, and it's going to make the ROI analysis even better internally to justify why you want to consolidate tools and move to something different.
Thank you for that insight. And one more question for you, Sergio. It is, given these new challenges, have you seen a change in how customers approach network and application visibility?
Absolutely. Absolutely. This is really top of mind for most of our customers and prospects. They recognize the challenges. And one big change I've seen is they're actually going at it with a way more proactive approach than before, rather than react to, I got an outage or my customers are complaining about a specific service and reacting to it. They're looking at this with a more proactive approach. And again, I think this is related to my initial statement that CIOs and their teams are really under a lot of pressure to ensure end user experience. Right? So we see that change.
Excellent. Thank you for those insights. That brings us to the conclusion of our event. I wanted to thank our audience for taking time out of your schedule to join us today. As I mentioned at the beginning of the webinar, you will be receiving a follow-up email with resources from today's webinar, so I hope you will check that out. Thank you again for joining us, and I hope we will see you at a future event.